Okay, C6 electrolysis test feedback. Use this information to mark your test, add some notes, correct things you may have got wrong. Okay, so hopefully this will explain some of the things you may have found difficult. Okay, first question. We are looking at standard electrolysis setup here. And you are asked which gas is produced at the positive electrode. You've got four options here: carbon dioxide, chlorine, hydrogen, oxygen. We're told here copper chloride is dissolved in solution. So we know there are four ions here. We have copper 2+, chlorine minus, and from the water we have H+, and we have OH minus. Okay, so if we look at the options that we're given, carbon dioxide is a molecule, so that is not necessarily going to be given off here because it won't be attracted to the positive electrode. It has no charge, so we can discount that. Chlorine is definitely in there and it has a negative charge as well. Okay, so that could be an option. Hydrogen is definitely in there, but it's positively charged, so it won't be attracted to the positive electrode, so we can discount that. Oxygen could be given off from the OH minus. However, we want to revert back to the rule that chlorine, being a halogen, if it's present, will always be given off in preference to anything else. So it won't be oxygen, the answer will be chlorine. Part B. Determine the mean mass of copper produced after 3 minutes. So we're determining the mean mass of copper after 3 minutes. Okay. The table of information gives us 1, 2, 4, and 5. So we want 3 minutes in between here. And if we scan across, we can see that the mean mass of copper increases by 0.6 every minute. So we just need to add 0.6 onto the 1.2, which will give us 1.8. Apologies, being a lefty, I tend to cover my work as I go, so it might be a little frustrating watching this. Calculate the mass X of copper. So calculate is our command word, and we want to know the mass of X of copper after 5 minutes. Okay, so we look back here, we can see X in our table, so we want to find the value for that. Now normally we would add the three numbers together, 1, 2, 3, and divide by 3 to get our mean. Okay, so we can write that as an expression. 3.02 plus X plus 3.01 is going to equal 3.06. Okay, so that's how we would normally calculate the mean. We need to rearrange this to give us, I've forgotten to divide by 3 there, sorry. So to rearrange, first of all, we need to get rid of this 3. If we divide it by 3 on this side, we multiply both sides by 3, which gets rid of that, and we multiply by 3 that side. So it's 3.06 multiplied by 3. Okay. So now that's 3.02 plus X plus 3.01. Okay. Rearrange it further. We can add these two numbers together, which gives us 6.03 plus X is 3.06 times 3. And if we're adding on this side, 6.03, we can subtract both sides by 6.03. So X will equal 3.06 times 3 minus 6.03. Okay, So this will be 9.18 minus 6.03. So the answer for x is going to be 3.15. Next question. Copper chloride solution used in investigation contains 300 grams per litre of copper chloride, and that's in 1 litre. They give the concentration here, 300 grams per litre. They also give you the volume. Okay, what is it they want you to do? Calculate the mass. So the mass is equal to the concentration times by the volume. Now here we have to make sure the volume is in decimeters cubed. They've given us a volume in centimeters cubed, so we need to convert that. So 50 centimeters cubed divided by 1,000 equals 0.05 decimeters cubed. Okay. So mass is equal to 300 multiplied by 0.05, which will give us 15. So the answer is 15 grams. Okay. The student investigates potassium salt X. She finds salt X has a high melting point, does not conduct electricity when it's solid, dissolves in water. So all this information here is key. They've given you that for a reason. What is the type of bonding in salt X? So high melting point, doesn't conduct when it's solid, it does dissolve in water. What type of bonding? So we've got a choice of 4 here. Now for me, the easiest way to look at this is if we have a salt, as they've stated here, then we know a salt is a metal and a non-metal bonded together. We know that covalent is non-metal and non-metal bonded together, so it can't be that. Giant molecular would be something like diamond. Ionic is metal and non-metal, dissolves in water, doesn't conduct electricity when it's solid, and has a high melting point. So that would be our correct answer. Metallic is metal and metal. Okay. What is the name given to solutions that conduct electricity? That is electrolyte. And why does a solution of salt X in water conduct electricity? And that's because it has ions that are free to move. And carry a charge. Okay, question 3. Aluminium is extracted by electrolysis. They give the diagram. Aluminium cannot be extracted by heating aluminium oxide with carbon. Suggest why. So if you go back to the reactivity series, we know that aluminium is more reactive than carbon. So carbon cannot displace or push out aluminium from its compound. Okay, so Al is more reactive than carbon, and carbon cannot displace aluminium from its compound. Okay, sorry, I'm off screen that. Why is aluminium oxide dissolved in molten cryolite? cryolite reduces the melting point of aluminium oxide. Okay, so it saves money. Aluminium metal is produced at the negative electrode, the cathode. Complete the half equation for the process. So aluminium 3 plus here, plus 3 electrons will give aluminium here. Okay, use the half equation to state why Al3 plus ions are reduced. So let's go back to oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. If we look at our equation, aluminium here has gained 3 electrons. Okay, so it has gained electrons. Okay. Explain why the positive electrodes anodes burn away. Use your knowledge of the products of electrolysis to help you. So what happens here, I'm going to try not to get in the way of the writing too much. When the oxygen, O2 minus, is or loses its electrons, it produces O2 gas, and it gives away its additional electrons to the electrode. Okay, so in our diagram, when the oxygen is produced here at high temperature, and remember these are made from carbon, the carbon and the oxygen react to form carbon dioxide gas. So a chemical reaction takes place. Oxygen produced at the electrode reacts with the carbon electrode to produce carbon dioxide. This gradually wears away your carbon electrode and needs replacing. Okay.